Viewers, thank you for watching this video. Our today's topic is physical quantities. What are physical quantities? Viewers, those quantities which can be measured are known as physical quantities. For example, in physics, we come across different quantities. For example, length. Length is a physical quantity. Mass of something is a physical quantity. Pressure is a physical quantity. Speed of a vehicle is a physical quantity. Height of some tree or a pole or a building is a physical quantity, because all these quantities can be measured. So we call the physical quantities are those quantities which can be measured. To further elaborate the concept, let us consider an example of another quantity. He is very brave. His bravery cannot be measured. He is very honest. He is very intelligent. These quantities cannot be measured, so they are not the physical quantities. Now, physical quantities are divided into two categories. They are known as types of physical quantities. One is called vectors and other is called scalars, or vector quantities and scalar quantities. Viewers, what are these quantities? Vectors, we can define them, those physical quantities. For their complete description, we not only need their magnitude on a suitable scale or unit, but we also need a proper mention of direction for their complete description. Such physical quantities which are completely described by magnitude on a suitable unit and also a direction is required, they are known as vectors or vector quantities. The examples of vectors are force, displacement, velocity, torque, and momentum. There are so many other vector quantities you will come across in physics book. Next, quantities are scalars or scalar quantities. For their complete description, we only need their magnitude along with a unit. No need of direction. These are also known as directionless quantities. Their examples are time, mass, speed, length of something, and current. They are placed in scalar group of physical quantities. Now students, since scalars are just numbers and we are very familiar with these numbers, but on the other side, in case of vectors, along with numbers, the directions are also involved. So the next thing is how to represent a vector quantity. When you write a vector quantity, it should be differentiated in writing from a scalar one. There are two ways of expressing a vector quantity. One is the graphical way. In a graphical way, a vector quantity is represented by a straight line having arrowhead on its one end, where length of the line gives magnitude of the vector on a suitable scale and arrowhead shows its direction. For example, there is a force of 5 Newton acting towards right. Force is a vector quantity and we will represent this force of 5 Newton with the help of a straight line. First of all, we will select a suitable scale. Say 1 Newton is represented on paper by a length of 1 centimeter. So that is our scale. 1 Newton equals to 1 centimeter. According to this scale, a length of 5 centimeter will show the force of 5 Newton. Towards right means we will put an arrowhead on that line on indicating the right direction. So this arrow represents a force of 5 Newton acting towards right. By this way, we can represent the vector quantities graphically on the paper. Another way of representing the vector quantity is a theoretical way. In writing, we represent a vector quantity with a bold-faced letter like A, or a simple letter having arrow above or below it. By this way, in textbooks or in our notebooks, during our writing we represent a vector quantity either by bold-faced letter, or if we want to represent it graphically, we will represent it with a straight line having arrowhead on its and that is representing the direction of that vector quantity. I hope the difference between the theoretical and graphical representation of a vector is clear. Thank you for watching this video.